Okay. So objectives for this next section is basically just to talk about basic networking concepts. So when you want to access anything that isn't necessarily like a virtual machine or attached to a network card, you pretty much just do it through the AWS API, and it doesn't really matter where it's located. It resolves through DNS, and you hit the API and you programmatically interface with it. But if you've got like virtual machines and you've got networking devices and all that, they have to live on networks. And so we have to talk about networking a little bit. Plus, when we've got our own data centers, we've got to hook those networks up to AWS's networks. And so there's different ways to do that. So we're going to talk about what those pieces could be. Now, traffic, we usually try to direct and control traffic. For example, we don't want people on the internet getting into our internal routers. If you're at a coffee shop, you don't want people placing orders directly with the baristas unless the barista is also the cashier, which, may be the case actually. So this kind of thing where they got cut around the line, you don't want that. How do we usually control network traffic? Well, we usually use firewalls and or routing. Control it. Routing basically says go this way to get to here, right? So there's a couple of ways for us to approach that. Now, in the Amazon world, VPCs or virtual private clouds are actually the primary way by which we control or define networking inside of AWS. Inside the VPC concept, there's a bunch of devices that can live. Now, VPCs actually do exist inside your account, and you have to create a VPC because they're region-wide. So every single region has to contain its own VPC. For example, if you wanted to run in Tokyo and you wanted to launch a virtual machine, you have to have a VPC in Tokyo. And then you have to create subnets inside that VPC, and the subnets are assigned to availability zones. So if you can imagine, since you have to run a virtual machine inside of an availability zone, it has to be on a subnet inside of a VPC. Let me say that again in case you missed it. Virtual machines have to live on subnets. Subnets are availability zone specific. They cannot span availability zones. So when you start a virtual machine, it has to run in a subnet in an availability zone that is part of a VPC that's part of a region. So remember that VPCs are a region-wide construct in AWS. Subnets are availability zone only constructs. One AZ and one AZ only. So think of this as like the counter area. Like you've walked into a coffee shop and there's like a restricted section, and this is where we've launched, in this case, our workhorses. Something kind of weird, a cashier and a barista, right? Now, we only want people talking to the cashier, so the barista's off limits until the barista delivers something, and then, right, we don't mind people talking to them then. But if you want to order something, you got to go through the cashier. This same concept of that there's resources that are front end accessible and there's resources that are only back end accessible. This is usually manifested in what we call a public subnet or a private subnet. Now, a public subnet is a subnet where the internet, it can get directly to the internet and the internet can get directly to it if the firewalls allow it. So I do want you to know there's always security at play here with AWS, always. I could argue that first and foremost, AWS is a security company, but a public subnet can get to and from the internet. A private subnet does not have direct access to the internet. So when we think about a VPC, which is just an organizational construct that has some networking information attached to it, and subnets are just networking constructs that have a lot of networking information attached to them. Not that there's much difference, but there is networking information. What happens is that if it's a public subnet, it can actually talk to this virtual device called an internet gateway. This internet gateway acts as a router that allows that subnet to talk directly to the internet, and if it has a published IP address, the internet can come talk to it. Now, the funky thing is that's how a public subnet works, but a private subnet can't talk to the internet gateway. By the way, this is all in the same VPC. Just to be clear, every single VPC has an internet gateway, but it's whether the private subnet knows how to find the internet gateway versus a public subnet, which knows how to find the internet gateway. That's the only difference. But let's say that you are running database resources and you don't want them exposed to the internet, which is really good practice, but you want your corporate networks to be able to get to these databases. You can actually hook your corporate data center up to your VPC using what's called a virtual private gateway, and it's going to run a VPN connection. Now, most of you work for large enterprises, so you know what a VPN connection is, because all it is you creating a private tunnel across the internet, an encrypted tunnel, which currently is using supposedly uncrackable mathematical keys and whatnot, right? Encryption. Now, this does run over the internet, so it is subject to internet speeds and internet weather, but it does allow you basically to talk, right, to this private subnet. Notice that we've got a corporate data center with a corporate firewall and router, and it is going over a VPN connection, and it's hitting what's called a virtual private gateway. By the way, you can set this up in a variety of different ways, but you have to have some kind of device that supports VPN as a protocol, IPsec in particular, over on the left-hand side, so it can connect with the virtual private gateway, which also supports IPsec. It doesn't support like, what was it? GRE, I think it's the other protocol that like it doesn't support. In addition, if you don't want to run it over the internet, you can actually run your own physical cable from your corporate data center to a router in an AWS partner location, and they in turn will run a cable connection from their data center to AWS, because you can't really know where AWS's connection is. They're not going to let you know that, right? But this is called direct connect. This can run, by the way, at fractions of a gigabit, 10 gigabit, or 100 gigabit speed. So just know that you can get really fast dedicated wire directly from your data center over to AWS. This still uses a virtual private gateway. You can also use what's called a direct connect gateway. You can also use what's called a transit gateway. A lot of different ways to set this up. But this is where you're running a physical cable. So this is not a virtual private gateway for VPN. This is a virtual private gateway for direct connect, which again is a physical cable. By the way, that is not encrypted by default. You can also run VPN across direct connect, so that your traffic's already encrypted. So you could do that as well. So in this particular case, you can actually see the connectivity points between, right, the customer data center all the way into the VPC. So in review, we got VPCs, which are networking pies, like networking, like, you know, they're networks basically that you define inside of your AWS account. Subnets are slices of that networking pie. They can either be public or private, means they're either connected to the internet or they're not connected to the internet. There's a public subnet with a connection to the internet gateway. There's a private subnet, no connection to the internet gateway. And again, if it's a private subnet or public, it didn't have to be private. You can actually connect it either through VPN over the internet, or you can use direct connect to hook things up. So just know that you have an option to just run over your internet connection, or you can actually set up your own dedicated pipe. Now, that leads to our next section. If I want to isolate some sensitive databases that contain customers' personal information, which of these four networking constructs on the right am I going to use if I want to isolate something? I don't want the internet to see it. Well, remember, if you're going to run your own database, that's going to require a virtual machine. Yes. Well, we're probably going to run that on a private subnet because we don't put databases on the internet. That's a great way to get them hacked. If we want to create a VPN connection between the VPC and the internal corporate network, we're going to need basically to run that over the internet. And so you need something on the end in order to make that work. What is the AWS construct that you need on the right-hand side to make VPN work? So in this case, you need a virtual private gateway. A VPG is actually what's used in order to terminate either VPN connections, direct connect connections, right, into your VPC. What if I want to support a customer-facing website that needs to be available across the internet? What am I going to use out of these two remaining constructs? That's right. We're going to use a public subnet, right? And then, of course, last but not least, if you wanted a dedicated wire between, basically an on-premise data center and VPC, you're just going to use Direct Connect. Okay. That's all like fundamental networking. There's also route tables involved, and there's like egress only gateways, and there's a bunch of other stuff that you can throw in here. Bottom line, though, is that what about security? Because I just mentioned that there's security at play here. How does that fit into the equation? Well, Amazon has two types of firewalls, right? So the first firewall, right, is that when network traffic comes in, the first thing the traffic has to do is it has to traverse the firewall that guards the perimeter, right, of the subnet. So for example, you'll see it here, is that when it comes in, the first thing it has to do is it has to get past this layer. This whole subnet right here is guarded by something called a network access control list. It has to get past this in order to even get to the second firewall, which the second firewall is this security group right here. Once it gets past the security group, then it gets back to the instance. The instance can respond, and then it will send traffic back along the wire back to the client. Again, having to get through firewalls at two distinct levels. Now, by default, these firewalls are not necessarily enabled for everybody to use because Amazon doesn't want to complicate your life right off the bat. But you can set up any kind of perimeter or setting that you need in order to make this work for you. By default, the firewalls will block all inbound traffic from the internet to any of your devices. So they're not going to let people get to your devices unless you say it's okay. That's the default. So here we got a packet coming in, hits the internet gateway. Then it has to hit this firewall that exists right before you get to the subnet. It's called the network access control list. And then it can get to the security group, and then it can get to the instance. And by the way, the reverse is true. Traffic initiated outbound has to go through the security group, then the NACL, then the internet gateway, and then it gets out. NACLs, by the way, are stateless firewalls. And by default, it allows all traffic in and out because Amazon doesn't want to make things super complicated by having two firewalls you have to mess with out of the gates in order to get things working. But you can easily turn those on, right? You can deny ranges, deny IP addresses. You can deny it based on port protocol traffic. You can deny UDP versus ICMP. That's up to you. By the way, if you don't specify an allow rule inside of your stateless firewall, by default, it's going to deny everything. So you got to have a rule that says you're allowing, because there's a deny rule that's always there. You can never remove. In other words, if you haven't said explicitly that I will either allow all traffic or allow this specific traffic, it's not going to let you do anything. But just know that this firewall is typically disabled by default if you're using the default NACL. Now we say that, just remember that network access control lists are going to do stateless packet filtering. You need two rules to initiate and respond traffic. Two rules. It's not good enough that you say that someone can have a conversation with Michael. You must say that Michael can respond. So just know that stateless packet filtering requires two rules because it doesn't track connections. It doesn't care who initiated the traffic. It's not tracking who did what. This is very different, by the way, than the other firewall. The other firewalls known as security groups, right, or SGs, these wrap around the network card inside of any machine. And it's a virtual firewall, and by default, it will allow all outbound traffic, but it's going to deny inbound traffic. So even though the other firewall by default in a default group is disabled, the security group by default blocks all incoming traffic, so you can't get to any box. This is a stateful firewall, which means you only need one rule to initiate a request and then allow a response. For example, if I said, look, Terry can talk to me, this firewall is going to assume that I'm allowed to respond to Terry. Because wouldn't it be weird if Terry was like, hey, and I can't respond? Well, if this was a NACL, I have to have a rule that says that Terry can talk to me and that I can talk to Terry, or at least respond to Terry, right? With a stateful firewall like the security groups, all I need is one rule. Terry can talk to me. Because the minute he talks to me, the stateful firewall is going to go, well, I'm going to assume that you're going to want to respond because Terry talked to you. So you can respond to him in that conversation. So just know, stateful firewalls can't handle as much traffic, but they're a lot like more like convenient, ease of use, a little bit more sophisticated. Whereas stateless firewalls are not. So remember, network access control lists are stateless, security groups are stateful. By the way, it says, hey, I'm leaving, but I'll be back. Okay, I'll see you when you get back, because a stateful firewall remembers that you initiated traffic and it will let you back in as soon as it sees you respond for that same traffic. Now, I'm really dumbing that down because if some of you are going, well, aren't there a bunch of security holes there? No, there's not. We figured this out. And don't get me wrong, things can be spoofed, things get weird. You know, obviously there are ways to make this crackable, but for the most part, we figured out how to make it 99.9% not crackable. You have to do something really silly to make that a vulnerability. There's always a way though. So in a VPC, just to like highlight this, notice that the traffic, if we spotlight this for a second, traffic's coming down this way. It's the internet gateway, gets past this network access control list, goes into the subnet, hits the security group, and then comes down to the EC2 instance. And then it just does it in reverse. That's it. So remember, this particular one is stateless, and by default, it's not doing anything. It's not enabled by default. This one is enabled by default, but the only thing it's doing is it's blocking all inbound traffic. It's allowing all outbound traffic. So then, that all being said, what is the major difference between a network access control list and a security group? What's the number one difference between a NACL and an SG? That's right. The packet filtering is either stateless for a NACL or stateful for a security group. Good. The other thing is, remember that NACLs are for subnets, SGs are for instances, like basically anything with a network card. So. All right. So we talked a little bit about the components of a VPC and the subnets and the networking there. We talked a little bit about the firewalls, which also stick inside of a VPC. So this is all, by the way, within availability zones and regions. So this is all core networking. All right, this is not edge networking, which is what the global network is, okay? So just be clear about this. Core networking with VPCs, edge networking is what we're about to talk about now. Okay, so I mentioned earlier that if we're using those points of presence or those edge locations, you're probably either using DNS, caching, right? Or you're doing some kind of like, you know, content manipulation. So just know that when you type in www.amazon.com in your browser, it has to resolve to a computer-based IP address. The system that does that is DNS. And we're familiar with this because if we've ever bought a domain name, we went to a DNS registrar when we bought the domain name. And that had to be pointed somewhere, right? So this is how computers get to resolve to IP addresses, then allow them to do things. Now, Route 53 is Amazon's DNS service. And this is like Amazon's kind of like GoDaddy. It's like Amazon's AWS's like name cheap if you're familiar with them. This is the DNS service, and you can buy domain names here from them if you so choose. I think I have one. I probably actually need to disable it. I don't even remember what the DNS name is. It's like something with OpenShift because I used to work for Red Hat. And just be aware that, you know, this is like the DNS service. So you can like do all the things you would normally do with a registrar. The cool thing though about this is that this integrates really tightly in with CloudFront Global Accelerator. And they really works together to make it so that when someone requests a DNS name, it sends the user to the closest edge location, like the actual closest like physical location. That's called proximity routing, by the way. And so it sends it to the fastest, closest location, that's more of a combination of latency and proximity. And then that server will intercept that request and acts as a proxy to do whatever it needs to do on behalf of the client to AWS. For example, if it needs to talk to a load balancer, it'll do that. This is how DNS works with CloudFront, works with Global Accelerator, which you don't see here, but Global Accelerator is like a global load balancer. But it works with DNS to make sure that the user's always redirected to the closest server. Not super sophisticated. The concept's been around for a long time, but doing it at this scale has been, within the last 10 years or so. So that's how the global network gets involved, is that CloudFront, Global Accelerator, Route 53, which is the DNS service, they work together to make sure the user always goes to the closest AWS infrastructure. Now, quick knowledge check about these concepts. If I wanted to establish a private, dedicated connection, not over the internet, between a company's data center and AWS, which of these services do I have to use? Good. So people to it C, direct connect. That's true. That's the one that establishes the physical cable. So that makes sense. Which statement describes security groups? Are they stateful or stateless? And do they allow or deny all inbound traffic by default? Read these out and see if you can figure it out. All right, so security groups are stateful and they deny all inbound traffic by default. That is accurate. So good. Perfect. All right, which component is used to connect a VPC to the internet? So for example, if I have a public subnet inside of a VPC, what does that public subnet need to talk to inside of AWS to get to the internet? Well, in order for something to get access to the internet, it needs some way to get like we use at home. We have our like cable modems. They act as gateways, right? And so in this particular case, the internet gateway is actually the device that allows you to talk to the internet. And don't get me wrong, it still has to get past the security group and the NACL, but those are firewalls. They don't directly enable, they just block it. But the device that truly enables you to get to the internet is actually the internet gateway. Good. Which service is used to manage the DNS records for domain names? We talked about this a little bit. What is the name of AWS's DNS service? Excellent. Good. Yeah, it is Route 53. Okay. So which statement describes DNS resolution? What is the whole deal? Why are we using, what does DNS actually do for us? Yeah, that's accurate. It translates a domain name like www.michaelricherforrester.com to an IP address, right? So this is what we spent the time learning, right? Is that we spent some time learning about the components of a VPC, some of the security of it, and a little bit about the global kind of services that are available for AWS, specifically CloudFront, which we already talked about to a certain degree, and in Route 53. Questions of any type, particularly while I'm transitioning?